So breaking this generic name down, what's the generic name for this mean?
Ketone, 5 carbons, second.
That good? Ketone, 5 carbon carbohydrate. Draw A. Okay, so CH2OH. Okay, so there's 5 carbons and a ketone. And why did I say draw A and not draw B? How many versions are there? Those two are stereo centers, right? We're okay with that? And so the formula to calculate that would be just 2 to the second. So it's 2 because it can either be L or D, and then there are 2 of them, so it's 2 to the second. So the possibility is there 4. In this case, it would be both hydroxyls on the right side, both hydroxyls on the left side, drawn like this, or drawn where they're flip-flopped, where the top one's on the right and the next one's on the left. So those are the only 4 possibilities. And what's our keto pentose look like in its cyclic form? Why does it look like a box when the other things that we've shown before looked like pentagons and hexagons? The carbohydrates have, I would say, a tail, meaning the very last carbon is not part of the ring structure. And so there are only 4 carbons that are going to be.
That's only 3 in the ring structure.
That's only 3 in the ring structure. Not bad. I forgot the CH2OH. There we go. So why is there another hydroxyl group sticking off the front of it? Because it's a ketone. So carbon number 2 is the carbon that's got the carboxylic, or has the carbonyl group on it. So for the fructose, when we looked at that molecule, it was a 5-membered ring, and there was a carbon hanging off of each side. And so this is 1 carbon less, because fructose has 6 carbons, and this guy only has 5 carbons. So that means I have 1 hanging off on each end, plus, or that only leaves me with 3 carbons to be in the ring structure, plus the oxygen. So when the carbohydrates go into their cyclic form, the aldehydes have a carbon hanging off on both ends, and the aldehydes have a carbon hanging off on one end. And so you'll always have 1 less than the total number of carbons for the ring structure for ketones.
Which one is your number 1 carbon?
I mean, it's completely arbitrary. It's just that that's how it's always been done. They count the carbon on the right as carbon number 1, and then moving around the ring structure to the top left is always going to be the last carbon in the carbohydrate. So, did you guys find a specific ketopentose? Ribose? That's a ketohexa, or it's a aldo pentose. It's definitely an ose, and it's definitely 5 carbons. It's just that's an aldehyde version instead of the ketone version.
Well, I imagine I'm wrong because you're wrong. I did a galactose, Venom, alpha D.
Why is it not letting me copy? Seriously?
Did have anything else?
Add to the dictionary. How do you like that?
That's by
Huh,
carbon.
that's very strange.
That's what I thought.
How do these things go? Here are 3. No, here are 2. So the one that I actually drew was just random. It was this how do you say that? Xylulose?
Where are you at?
Xylulose. That's a terrible name, but okay. Yeah, great. List the linkage for bondage for the sucrose. So the sucrose it's an alpha 1 beta 2, and the maltose is an alpha 1 4, and the lactose is an beta. Oh, I'm sorry. This is beta. Yeah, my bad. Beta 1 4. And then the lactose is alpha.
Isn't the lactose the beta 1 or? And the maltose is the alpha 1.
So yeah, you're right. It's alpha 1 4 because it's. That's the maltose structure. So this is carbon number 1 here, and so that's alpha down, and this is carbon number 4 here. Yeah, okay. And so then beta 1 4 for for the lactose. And what are the monomers for the sucrose? What are the monomers?
For sucrose,
Okay. Okay. So what is it that?
Those are like alpha D glucose and beta D fructose.
They're all D, yeah. We can't metabolize the other form. So how do humans make fuel out of carbs? What do you do?
Ferment yeast.
Yeah, the easiest thing for us to do is,
Make an alcohol.
yeah. So just fermented alcohol, and then the vehicle can run off of that. So have you seen different versions? How about this? I don't know, I think it was maybe 3 years ago. I took a lawnmower in to get tuned up, and the guy who was doing the tuning up on the lawnmower, all he wanted to do was complain about the ethanol and the gasoline destroying all of the gaskets and seals inside of the lawnmower. So why do you think that's the case? It dries them out. So why doesn't Briggs and Stratton just make seals so that doesn't happen? They're behind the times. That's not really, they don't want to sell seals because the seals cost almost nothing. It's all labor. So they don't really want to have the reputation that every season you have to take your lawnmower in for an overhaul and get the seals replaced because people are using ethanol. So they are literally, they're like, oh, it didn't really dawn on us that every state in the country now requires how much in their gasoline, how much ethanol?
Like 10%.
It is, by definition, you're gonna have 10% ethanol inside your gasoline. Is that a big deal? It is when you're what?
A seal.
It is when you're a seal?
A gasket or a seal.
Oh, yes, okay, sorry, I was thinking of the other seal. Actually, there's a really sad story. 2 sea lions got stuck in the trap door that is supposed to keep them out of a section. Yeah, and they drowned down there in Bonneville.
Aww.
It was a mad rush to get to the fish. Somebody got stuck. 2 actually got stuck. Anyway, so the seals themselves can be broken, but the fact that there's 10% of your gasoline, I mean, how much gasoline does the United States use? Lots, right? So if you can get rid of 10% of the gasoline use and its ethanol use, then that does 2 things for us. What are the 2 things that it does? What are the 2 good things? Yeah, first off, it's less emission. Because how many carbons are in an ethanol? 2 versus how many in a 8 in the octane. You do get less power out of the ethanol, but on a volume, on a gallon per gallon level, the ethanol will provide more bang for the buck. If you go to a drag strip, they've got cars that run off of different fuels, and one of them is the alcohol cars. And so those guys run off of alcohol. They're run incredibly hot, and they produce a great deal of power. So great, we have less emissions. Why else is this a good thing? It is less expensive. What else? Second biggest, third biggest lobby in the country? So when people think about corn, they usually think like, I don't know, Field of Dreams, like a guy planting corn and harvesting the corn. Most of the corn produced in the country is not produced by a family, it's produced by a corporation. And those corporations spend a great deal of money to keep the federal government giving them money to make more corn, of which we will turn a portion of it into ethanol for fuel. So these are like 3 good things about ethanol. What's the bad thing about it?
Our corn's genetically modified.
Stop.
Taking jobs from the farmers.
Shh. Food price goes up. If instead of making something that you can eat with that corn, you are putting it into a gas tank, and we're not the ones that are hurting from it. Third world nations are the ones that get hurt by it. We have less corn to farm out to everybody, and so the corn that we do farm out costs more. What are the other types of ethanol that you could get at the gas station?
I don't know about that. I was reading that Brazil uses sugarcane.
You can go buy yourself some E85. So when this is on, say like it's on most vehicles, not most vehicles, it's on a lot of vehicles, and all the manufacturers have their own versions of E85. Ford calls it Flexi Fuel. I forget what Chevy calls it, but what does this E85 nomenclature mean? Say again?
Is it EcoBoost for Chevy?
No, that's Ford.
85%?
It can be up to 85% ethanol. So you can pull into a tank, a gas station, and that gasoline will only actually be 15% ethanol, octane, 15% octane, and the rest of it's going to be ethanol. You cannot put this in any old vehicle. If your motor is not designed for this, your motor will not be functioning for too long. This should be much, much cheaper, but it's not a lot cheaper, mainly because there isn't a lot of it on the market. It's literally a supply and demand kind of thing. Okay.
So it only had that one native food truck?
Yeah. Yeah, it's a pretty big worldwide negative, right? Food costs go up. I guess the other thing is, do you like to give large corporations money for doing what they do to make money? I don't particularly like that. That kind of thing drives me crazy. You're gonna make $3 billion selling corn this year, and we're gonna give you $800 million to make corn? I don't get that. It's a serious faux pas for a politician to talk about ethanol, though, in a negative light. Why? Where's the first presidential primary held? Iowa. What do they have in Iowa? Anybody been to Iowa? I have.
Yes.
They have cornfields. That's it. They have corn. You could fall asleep driving at 100 miles an hour, because I was being passed and I was driving 80. I was being passed like I was standing still by those people. You could fall asleep and just drive off into whatever and wake up in the middle of a cornfield. You're not going to hit anything. That's all there is in that damn country, or that state, is corn. So you cannot talk bad about ethanol, because that's where they get money from. They want the ethanol subsidies. Okay, so this and this, they both have carbs. How do the carbohydrates differ? Yes, this is a disac, and this is a mono. So the bee, when the honey gets created, it's a disaccharide, but the fact that it's slightly acidic busts the two apart. So you do not have sucrose inside of the honey. You've actually got the two molecules, the fructose and the glucose, independent of each other. So why the honey stick right before you go in?
Straight into your bloodstream.
There's no breaking down. It goes into your system. It takes a minute for it to hit your small intestines, and it gets thrown right into your bloodstream. So it's instantaneous energy. And since you're going to use it right this second, it's okay that a little bit more than half of it is fructose, because it won't get turned into adipose tissue, because you're going to use it right this absolute second. And the chocolate bar about 10 minutes before, what's the deal with that?
Gives it enough time to break down.
Enzymes in your stomach to break it down into its components.
Definitely not in your stomach, but
In your small intestine. But it gives it enough time to be ready for the demand.
so the honey needs no digesting whatsoever. It's just transported into the bloodstream and good to go. And the sugar in the disaccharide in the chocolate bar needs to be busted, so it's going to take a couple of minutes to do that. Okay, what do we got here for benefits and drawbacks for artificial?
Drawback is that it gives your rats cancer.
Yeah, that's not going to get written up here.
I wrote it on mine.
This feeding that rat Splenda all over.
Aftertaste.
It wasn't Splenda, it was Sweet and
Yeah,
Low.
it was sweet and low.
And before the rat dies of cancer, they're going to starve to death because you fed them something they can't metabolize. So you're a terrible rat owner. Don't do that.
The benefits is that it costs less to produce. It takes a hell of a lot less than sugar.
Sure, it does cost less. You buy an equal sweetening amount of Splenda versus table sugar, and it's a lot less.
6,000 times sugar.
There's a lot of recipes that you can't use that
What?
stuff.
Less land
Doesn't
devoted
make-
to production, right?
Lab takes up less land than a sugar cane field.
Yes. Nobody's said the first thing people say. Yeah. Okay. So it's calorie free, so it'll be good for a diabetic who's having trouble controlling insulin, and for somebody who's trying to lose weight. There are some studies out there that talk about diet drinks not helping, that people who drink diet drinks are amongst the ones that need to lose the most weight. And I have still yet to see a study controlled for the other food that the person eats. So yes, I ordered a large Diet Coke, which is not caloric, but that large Diet Coke came with a large fry and a Big Mac. So it's not the same thing. When somebody finally dedicates a study to controlling all input factors of food, which is really hard to do because it's really tough, even though if you're paying somebody to get them to say exactly what it was they ate, for a whole bunch of reasons, not to mention the psychological ones about I don't want to tell somebody when I've done something bad, so I just hide it. But the best study that I have seen recently that's ongoing right now is putting a person in a chamber that is completely contained. There's no input or output of any, even gases. So all the oxygen that the person has is in that container that whole time. And so they eat and breathe and sleep and do whatever they do for 3 days inside the container, and they're checking all of the output of all the gases the entire time. How do I know how much a person's ate? Where does the sugar go where does the carbon from the sugar go when you're finished with it? You breathe it out. So it's very simple to figure out exactly how much sugar has gone into this person's body, or exactly how much sugar that person has burned off in the form of glycogen or adipose tissue, because it came out of their mouth. You can't get anywhere around it. This isn't, we're not talking about feces, we're literally just talking about exhaling. And those people will probably publish in the next year or two. It's an extensive study, but it'll be interesting because they will have controlled for all factors. The problem with a study taking so long is they only have one chamber right now. The chamber thing's super expensive, and you can only put one person in the chamber at a time, and so it's not super, you can't get like 50,000 people all doing the experiment at the same time. Drawbacks?
Aftertaste.
Okay. Or just aftertaste, or just taste in general, right? Some people know it right away before they even aftertaste it.
Available energy.
There's no calories. You can't give a Diet Coke to a starving person and have anything happen except they become hydrated. I'm sorry, somebody said something?
Stereotyped.
Huh?
It's stereotyped by people because of cancer.
I don't know what you mean by that. People, like somebody saying you're gonna
Like
get
I'm
cancer
right,
from the Coke? Oh. Okay. One response is just take a science class. That's the answer to that. Something else?
It's made me
Okay. Not natural. I'm sorry, I'm gonna erase that. Because what is that? That's a polyatomic ion cyanide that's naturally made. How much of it do you want? None. No, thank you. Black Mamba Venom, totally natural. 100% organic Black Mamba Venom. Do you want any? No. The whole natural thing drives me crazy.
Venom, you said?
Is that why you had to instantly erase it when you wrote it?
I hated you.
Where'd they get it?
You could get Black Mamba Venom.
What's a black mamba?
Oh.
Poisonous snake.
It's a tiny poisonous snake.
Where is it at?
Africa.
Oh, Africa.
They actually found some in Louisiana, Georgia.
They would found like some in the United States.
Yeah, all people letting them go. Yeah, pets let go, like the pythons that were being let go in the Everglades, and they're just like eating everything. Like they have no real natural predator in the Everglades, so they're like 15 feet long and like eating mammals, large mammals now.
I think during Hurricane Katrina, like tons of pet stores destroyed like all kinds of
Yeah,
snakes and
that was
different animals got out.
one of the things that people were like, yeah, all these pet stores, all these snakes are just out and about. The snake doesn't care. Sweet, look at all this food laying around.
Yeah. Putting bounties on them now. The snake.
They are putting bounties on them, yeah. It's not just the pythons, but the boa constrictors are like rabbits as far as how fast they breed. So they're really clamping down on those, or trying to. So what's the lactose molecule look like? What do I need?
Lactose and glucose.
B, or beta, D, no lactose, and alpha, D.
So are we okay with this being D beta glucose? How is this D beta glucose?
It's not.
It's not?
And beta doesn't have to go down.
No, alpha's down. So no, number 4 is down always in a glucose. So what I have highlighted yellow is means D, and what I have highlighted green is beta. So if that highlighted yellow portion is down, then it's L, and if the highlighted green portion is down, it's alpha. I should probably erase that.
I think I looked it up in our.
So what do I have to connect it to?
Alpha D galactose.
An alpha D galactose. So what does my galactose look like? I gotta get this out of the way. What's the galactose molecule look like?
Glucose, but let's see. Carbon number 4, sucrose is C is
Oh, is that what you were saying, Michael?
Yeah, I got mass backwards.
Okay, all right.
I think mine are, did you get it out of the notes? Sure.
So that I don't know whatever color that is, red, orange, whatever. That's alpha in your galactose, right? So the orientation has to be like this. Does that make sense?
What if they're both moved over?
We don't talk about it like that. We draw them in a specific way.
Okay, well, I got mine off this page here.
It's the same thing. It's not?
No,
Well, it's just.
unless
you
I
have
mixed,
the
which was.
Alpha D
lactose.
glucose with the beta D galactose.
Let's see.
Maybe
You
we
wanna
would still
mix them all?
connect the same.
Right after it says left.
It is backwards.
That's what I did.
Actually, the way you have it here, would that work with the glucose on the bottom, that carbon sticking up in the way?
Just a sec here. So there's my OH that's up. And then
That's not glucose on the bottom.
yeah, that's galactose. Right.
And so, and then I called the one on the right, I called it alpha D glucose.
Yeah, and so
Beta
these,
D galactose on the left.
does it really matter if it's alpha or beta for the glucose?
So it's there down the side, it reacts, so it's out of the way.
Yeah, so we're just reacting carbon number 4, which is down, so it's always down.
Or is it-
Yeah, so then these guys react, and then I get a water molecule out of this, and then I've got a bond from right there to that oxygen right there. And so they're linked by, what kind of bond is that? A carbon, and then an oxygen, and then a carbon? Ester has to have a carbonyl group attached to one of the 2 carbons that the oxygen's attached to. And we don't have that with this. So all the disaccharides and the polysaccharides are ether bonds. You okay with that? It's a carbon and a carbohydrate bonded to an oxygen bonded to another carbon and a carbohydrate.